Good morning, everyone. Wonderful to visit you. I left Johannesburg early this morning. I work in Braamfontein, that's where the university is. It's a rough place, we have many problems there as well. Not flooding, but hijacked buildings, buildings that catch fire, gas explosions, drive-by shootings affecting our students last year. So I'm a climate modeler, but increasingly we are focusing on flood risk on the east coast of South Africa. I'm also here today to learn about everything that you are doing as the coalition, so that our research can hopefully find maximum uptake in your work. And many thanks to Kira and Talia of Groundwork for the invitation. Our institute does a lot of work also nowadays with eThekwini of the city itself, the Department of Water and Sanitation. I think you've built up an amazing community. So my role is very specific. It's to talk about how climate change are making things worse here in KwaZulu-Natal in terms of flood risk specifically. And in the talk, there are some technical slides I must also warn you for the sake of the university people here. But in the end, there's also a message of future change, looking forward into the climate future of this part of the country. So everyone, let me just first update you with what's happening globally. The unfortunate news I must share with you today is that the Paris Agreement on climate change has failed to reach its first objective. Its first goal was to try and keep global warming below 1.5 degrees Celsius. Right. That is now gone. Last year, as depicted by the red line there, was the first year during which global warming exceeded the first dangerous level, 1.5 degrees Celsius. Now, at the current rate of carbon dioxide emissions, the remaining carbon budget that can still keep us from exceeding that level permanently will be burned away in the next 3 years. With the United States having withdrawn from this agreement just now, becoming effective in a year from now, and with China also not having committed to achieve carbon neutrality by 2050, there's no way we are not going to see the permanent exceedance of this 1.5 degrees Celsius level. And why is it important for us in KwaZulu-Natal? Because the science is clear that once we exceed the 1.5 degrees Celsius level, and we are now basically exceeding it, the IPCC, the Intergovernmental Panel on Climate Change, found back in 2021 that we should expect more heavy rainfall events in eastern South Africa. And for as long as we continue to warm the atmosphere, the more severe that risk is going to become. So this world is a more dangerous world for us, this warmer world. That's the first message. Now, before we talk about Durban, let us just take note of the fact that these extreme rainfall events are now being seen occurring more frequently everywhere in the world. Not even in the United States, the superpower, are they safe from these events. So this specific slide is from that Kerr County disaster of the 4th of July. Right? And I think well over 100 people died in a massive flood. And why I want to start with that this morning is I want to just read to you what the Kerr County judge said in one of the first news conferences while these floods were still ongoing. He said, "Rest assured, no one knew this kind of flood was coming." And yes, that's not something to make us rest assured, right? But what he meant was, no one told them that a flood of that magnitude is possible. Because in one part of the river, the level of the river rose with 8 meters in 45 minutes. Right. That's impossible to imagine. So he said, no one told us this is possible. But of course, there are now all kinds of questions about the early warning system and the uptake in that specific county and in Texas. But that's for the Americans to work out. the point is we are seeing these extreme flood events occurring in basically every inhabited part of the world. So it's not only for us in South Africa. So back to Durban. When I started to see the images coming in from the floods on the 11th and 12th of April, of course it made a huge impression as me also as a climatologist. In the end, we are classifying this as climatologists as the worst flood disaster in the country's history if we look at the loss of life. 544 people having died. I guess many people here can tell me more what the cost estimates have come down to in the end, but the latest I've seen was $8 billion US dollars. It's massive. And 40,000 people displaced. Now, what happened? So for me as a climatologist, my work is on this part of the flood. What caused the flood? It was a cut-off low pressure system. We have about 10 of them occurring every year in South Africa. 2 out of 10 cause flooding. So it's a reasonably common occurrence that a cut-off low causes heavy falls of rain. In this case, there were 2 weather stations from the Agricultural Research Council that reported 500 millimeters in 48 hours. That's massive, colleagues, that's massive. The average rainfall here is 1,000 millimeters per year, right? So you got here half of a year's rainfall in 2 days. So no wonder it was a massive risk immediately. And that it happened in April, that's a record for April. That's a record event for April. There have been similar floods, I think you all know, of course. I think the most well-known flood in Durban, the most infamous flood, was the September 1987 flood, when more than 509 people died. And the rainfall was something in the order of 700 millimeters in 3 days, something in the order of that. That was also a cut-off low. April 2019, when I think it was about 70 people who died in this part of the world. That was another cut-off line. Another infamous flood in South Africa is Lionsburg, January 1981, Western Cape. It was another cut-off line. The Mthatha floods of June this year, another cut-off line. We lost another 100 people. So the first point I want to make is that these cut-off lows are part of our natural climate system. So we can't just say it's climate change. Right. I want to talk today about where did climate change come into this event. So there we saw President Ramaphosa. That was on the 13th of April. And maybe many of you remember when he visited some of the communities that were affected. And this photograph has always made a big impression on me. But on the scene, while he was walking here, he said, this disaster is part of climate change. It is telling us that climate change is serious. It is here. And then the phone started ringing at our institute, right? Because now people started to ask, is the president making a scapegoat of climate change for what happened? Right? So the reality is that there were some questions around early warnings being issued around the time of the flood. So was it only climate change? Where I live in Tshwane, we have more than 100,000 families living below flood lines. That's a reality. In South Africa, we have hundreds of people living below flood lines. So when there's a flood event, you can't just say it's climate change. You can't just say it. What is the proof that climate change played a role in the floods? And it's when the president said this that we decided at our institute, we are now going to develop a climate modeling attribution system that can really answer the question, quantitatively. What was the role of climate change in the Durban floods? Right? And that is important for various reasons. Policy, loss and damage considerations. But along the way, as I will show, we will also learn something about early warning systems, adaptation, and so forth. So it took us 3 years to answer the question. The president, in the end, we got the same answers that the president already knew on the sea. Right. 3 years later. 3 years later. But now it is quantified. Let us talk a bit about what happened. Then I'll start to show some science results. So this was subtropical storm Isa that caused the flooding. Yeah, if you know a bit of meteorology, you immediately think that isn't that a tropical cyclone? But because it has that cloud-free region in the middle of the storm, the eye of the storm, right? This is the first time in recorded history that a subtropical storm formed south of 30 degrees south. We've never seen it before. So a cutoff low, the cutoff lows when they move from the interior to the coast, they usually cause a little low. And that low is always important for heavy falls of rain, Eastern Cape, KwaZulu-Natal. But in this case, the low became tropical. Right, and we haven't seen that before. And that was another reason to investigate what happened from a meteorological perspective. And there was one other reason to do this research. Loss and damage is becoming a big consideration internationally. This is about developing countries having the opportunity to claim for damages from the richer countries responsible for global warming. Right. This is the principle of loss and damage. It's now part of Article 8 of the Paris Agreement on Climate Change. There was a breakthrough in 2022, a few months after the floods, at the negotiations COP27, when it was agreed that a loss and damage fund should be established. And the fund eventually, for practical purposes, became operational in January this year. Okay, there's almost no money in it, unfortunately. Right. No one is yet contributing. Okay, there are some symbolic contributions that have been made mostly by European Union countries. But the point is, the principle of loss and damage is acknowledged in the United Nations negotiations. But the contributions to the fund is at this point in time voluntary. And it's counting on solidarity between countries. It's counting on that. Then recently there was the International Court of Justice case that many of you may have seen, where the court has now ruled that the countries responsible for global warming and greenhouse gas emissions can indeed be held responsible by developing countries affected by climate change. Now, the type of science that I'm going to show you today, attribution science, figures out to what extent climate change made a disaster worse, or did it maybe cause a disaster. It's possible that this science will be used in future loss and damage considerations across the world. So my work was more in support of the developing countries in Africa, or our research, to give them a scientific basis to argue for compensation within this framework. Thanks for saying that. Yeah. Thank you. The students never applaud like that. So, all right. So now it gets a bit technical. So we have this wonderful computer in South Africa, a high-performance computer. It's almost a supercomputer, but it's an investment of the Department of Science and Innovation in the country's science. With this computer, we set up this detailed modeling system for Durban, larger Durban area, simulating the state of the atmosphere to be exact, 3.8 kilometers, very high resolution. So we were able to simulate that subtropical low that was so important in the flooding. So how do we work out if climate change made the system worse? Well, we used the climate model to simulate the actual disaster. We compare the simulations to observations. We test the model. If necessary, we improve it. But in the end, this thing that is known as attribution science is actually so straightforward. What we do is we take that weather system that caused the flood. In this case, it was a Qatar flood. And we place that weather system in a world that has not been warmed by the greenhouse gases. Right, that's it. That's it. So we take the weather system, and in most cases we place it back in, say, 1800, long before there were these large quantities of greenhouse gases floating around in the atmosphere. Now, to do that requires certain techniques and statistics, and one must look after the physical consistency of the simulations. But attribution science has developed over the last decade to be able to do this. In the end, what we did is we made 64 weather forecasts of the actual system. So just like the weather service would run a weather forecast, we ran 64 different weather forecasts, because if you know a bit about this science, there's always uncertainty in the weather forecast. Right? We all know that there's uncertainty. You can't have only one prediction. We made 64. We got a range of possibilities of how the weather system could have behaved, including what really happened. And then we had a corresponding set of simulations for the pre-industrial weather system. Then we compared the two, the statistics. Then we can see how the system was less intense or more intense for what happened in April 2022 compared to what would have happened in, say, 1800. That's what we've done. So we focus specifically on this, the statistics I'll show you specifically for this box here. And that is an area that contains the catchments of the major rivers that bring flooding into Durban, the larger Durban area. I'm also just happy to report that we now are running a new project where we are actually simulating the actual flood events in the rivers, such as the Umgeni, into the future. That's another project that I can report on in the future. But in the work that I'm going to show now, we focus on the rainfall, but future work does the actual river modeling in a changing climate. For this work, we've received wonderful support from the City of eThekwini, Department of Water and Sanitation in KwaZulu-Natal, and Umgeni Utukela Water. All these colleagues are supporting the science, sharing data sets, giving advice. Really, really positive. But let me then get back to showing you the findings. So firstly, with our high resolution model, we were able to simulate this low pressure system that formed in great detail. And we were able to replicate the rainfall that occurred. So as you will know, if we look there at observations and the model simulations at the top, along the coastal areas around Durban, most places reported more than 200 millimeters of rain over the 2 days. That's excessive. In that Durban area, close to the coast, many South African weather service stations reported more than 300 millimeters in a 24-hour period from the morning of the 11th till the morning of the 12th. And for the stations that measured over the full day, 2-day period, as I've mentioned, some of them reported more than 500 millimeters in 2 days. It was a massive rainfall event. Now, why is it possible that climate change made the floods worse? I will soon show that it did. But in order to understand what may have happened, we looked at the trends in climate in this part of the world over the last 4 decades. And that is where it now starts to become important, colleagues, for thinking about risks here in the future. The first thing to take note of is that Here in this part of South Africa, you are living in a wonderful part of the country where we have this warm ocean current to the east, the Agulhas current. That's what makes eastern South Africa so wet. It's the Agulhas current. The warm water, all the evaporation above it. Right? This is why it's such an amazing, green and wonderful province. But this Agulhas current has been getting warmer. We can clearly measure it with satellite measurements from 1979 when the satellite measurement started until today. That ocean current is getting warmer. The Indian Ocean to the east is getting warmer, and that is a risk because it means there's more evaporation. Very logical. Right? There's more water drifting around here over the ocean than 40 years ago. And that is the first ingredient for potential flooding. The second important aspect is, as we warm the atmosphere, we see it across the world, the atmosphere can hold more water vapor. That's a principle from thermodynamics. The warmer the air is, the more water vapor it can hold before the water vapor saturates. So here we have a wonderful source of water vapor. And temperatures have been rising. The other important aspect is that the wind patterns are also changing. So over the last 40 years, the circulation and the wind patterns have changed in such a way that we can get stronger southeasterly winds here when a cut-off low forms. And that just means there's a long path over the ocean. The southeasterly winds take, gathering moisture, then getting that big influx of moisture above the Agulhas current, bringing all that moisture into KwaZulu-Natal. So the long-term trends of climate is making KwaZulu-Natal more flood-prone. When there's a cut-off low that forms today, it has much more moisture that it can turn into rainfall than it had available 40 years ago. So now, just to start finishing up the results section, and then I'll have some conclusions. So that's the green dot. That green dot is where cyclone, subtropical low, Isa was. Not a full-blown cyclone. In the middle of the day, on the 12th of April, these black dots is the different positions simulated by our model where it could have been for the actual event. Okay, it's a bit technical, but just a typical weather forecast spread of the location of the low. The cold, these blue dots, is where the low would have been 40 years ago without the warming. And the red dots is where it would have been in the future, right, for this specific cutoff. So the interesting thing is that as we have these stronger southeasterly winds building up, there's a systematic northward displacement of these lows. Now, if we compare the pressure of the actual weather system to a cooler world and to a warmer world, we find that the actual weather system had a higher central pressure in April 2022 compared to a cooler world, and that's just because it assumed a subtropical nature, so it became in a way less of a mid-latitude low and more of a tropical low. Okay, that's very technical. Let me get to the important result, the rainfall. So this is now the heart of the finding. Here we can see the difference in rainfall simulated for what happened in April 2022 compared to a world without anthropogenic warming. And you can see that the rainfall was in the order of 40% higher over the Durban area, or even more. In this case, we've removed from the atmosphere, to get a weather system into the pre-industrial world, we removed the trends in temperature and the trend in moisture. So all this additional moisture that the system got from the Agulhas current we removed. All the additional heat that it got from the greenhouse gases we removed. So then we simulated the system for what really happened versus in the pre-industrial world without the effects of heating and moisture. So that is the final result. This is the final result. This is just the temperature effect. This is the temperature and moisture effect removed. So this is the most realistic result. And here we can see large rainfall increases for what really happened compared to what would have happened in the 1800s. So this is the modeling telling us that the rainfall was substantially higher. Now, by how much? I'll show some other graphs now, but it works roughly like this. There were 2 weather stations that reported more than 500 millimeters of rain in 48 hours. Without the global warming effect, we can estimate that their rainfall was supposed to have been about 250 millimeters to 350 millimeters. About 250 millimeters if we look only at the temperature effect. Then it would have been as about 350 millimeters, but if we remove temperature and moisture, about 250 millimeters. Right. So you can see there still would have been a cutoff line, and there still would have been heavy falls of rain, but it could have been about half that it was if we did not have the effects of global warming at work. The last technical slide before I conclude. Right. Thanks for hanging in here, everyone. This is some real science. Okay. Okay. So this is what really happened. There's the one weather station of the Agricultural Research Council. There's the other one. Right. Measurements at points, 500 millimeters in 2 days. These are the model simulations, and they show us that in this model there are some of the simulations that simulated even more rainfall. But I should just point out another technical point. In this case, our model simulated the rainfall over 4 by 4 kilometer square grid boxes. So it's area averages. So we can't expect the model to give the actual totals measured at points. Models are always a bit smoother than reality. But on the average, our model simulated an extreme rainfall event, maximum rainfall in this area of about 300 millimeters over 2 days. In, maybe about 350. In a cooler world, it would have been substantially less. But now, and this is maybe now the most important thing I want to say today, we then repeated this experiment. And we assumed that the world's going to continue to burn fossil fuels for the next 20 years, right? And then we assume that the cutoff low comes back in April 2045. What happens then? It simulates now, instead of an average total in the order of 350 millimeters, the averages are approaching 600 millimeters. And the individual cases are 800 millimeters. Okay. So that's why I thought I must accept Kira's invitation to come today. I'm deeply concerned, Colin. I'm gravely concerned. Because what happened in April 2002 was absolutely extreme rainfall. But the climate model tells us it can double. There can be a doubling in the next 20 years if the greenhouse gas emissions continue. And that means we have to absolutely, I wish we can start phasing out the greenhouse gas, the fossil fuel dependence, right? Then we can stop this from ever happening. But if it never, this is not in our hands, right? We can't control the United States and China and South Africa. They are trying to control us at the moment. But we must prepare, right? We must do everything that we can. That's why your coalition is exactly what is necessary, to prepare for what's coming. So to conclude then, we did a great deal of analysis to understand the weather system. I think we are contributing to understanding how the future low pressure systems will look like. So our finding, which has now been formally published, went through all the peer-reviewed processes. we made a formal assessment that climate change made this rainfall event worse by a factor of between 40% and 107%. So when we say it has increased of 100%, we mean it doubled in intensity. So the rainfall in our simulations, when we look at the effects of climate change in terms of temperature increases and moisture increases, our simulations say climate change made this event twice as bad as it would have been. That's in terms of the rainfall totals. The other important finding from the study is that the 2040 cutoff lows can be even worse. We just had another one of these events in Mthatha. It's part of our climate system. We have to prepare for the next cutoff low. I mean, this summer can be bad, this autumn, this spring can be bad. It's an immediate risk. So I think what I can contribute to your discussion as a climatologist, obviously we need the best possible early warning system. Right? So the South African Weather Service must be top-notch in their forecasts. And where they can link with the eThekwini efforts to build local flood forecast systems, that's a great thing. We need the best possible early warning systems. But there's something that's even more important, the uptake of the warnings. That's perhaps where this coalition can make a huge difference. So what do people do when they get the warning? We've just lost another 100 lives in the Eastern Cape. We have to get people out of the path of the flood. If we can forecast it with 2 days of lead time, even a day, there is a chance to evacuate people. So we have to learn. I mean, that's very difficult, but the experts here can think how to do that. But what I can say as a climatologist, the next flood is most certainly coming. So how are we going to get people out of the path of the danger? Then I think in our own research, we are now going to focus, working with the city, specifically on projecting future flood lines. So in a climate change, the flood lines will also change. It's going to become worse, the threat of the flood line. So the flood lines of the next 50 years are not the same flood lines as those of the last 50 years. That's our next research contribution. And then the long-term resilience, linking to the Safe Housing for All program you have. We should not accept that our people should live in these dangerous places forever. It's the same way I live in Tshwane. We shouldn't accept that people should always be exposed to the flood risk. That's a challenge for all of us in South Africa, how to get our people to live on safe land, to have transport to where the jobs are, access to water. But what I want to contribute, and that's the last thing I'll say, there's really international funding available. For example, the Green Climate Fund is increasingly funding these types of projects. So, yes, we should get our own economy going, and we should try to fund, the more of this we can fund ourselves as a country, the better. But there is also international funds available. And I think we must increasingly tap into the new Loss and Damage Fund to help us in this part of South Africa. And we should tap into the Climate Adaptation Fund to help us build resilience to these floods on the longer term. Thanks, Kira and colleagues. That's it. Thanks.
You made some very key recommendations at the end, what needs to be done, early warning system and others. This is something we've been doing some projects also with the eThekwini municipality, trying to collaboratively work together on a number of other climate change related issues and hazards and so on. And one of the things that maybe, I don't know what you think about it, is climate change literacy. That very interesting document that you cited, the IPCC document 2002, actually produced a map of Africa showing climate literacy rate, and South Africa is sitting at the bottom. So really, apart from just thinking about moving people to safe ground and the early warning system, I think we need to invest very seriously on education, climate change literacy. Thank you very much.
Thanks for your presentation and your study, which is really eye-opening. My questions would be, I'm interested in the statistical significance of your study. Maybe if you can tell us how much of a percentage is attributed to climate change vis-a-vis to current flow, because we want to understand the conclusiveness of the study. Then the second one would be if you can also share the limitations, the gaps and biasness of the study so that we can understand it holistically. Then the last one, would you be willing to come and share, because yesterday I was with the Troika, we were talking about your study and the significance of it. And would you be willing to come and share it to the leadership so that we can process the study and see how do we move forward? Thank you.
It will be a privilege to talk to the Troika, of course. Thank you very much. I'll be most happy to do that. And then I'll just say, so in these results, we compare statistically what we call the population of the simulations of the actual event to the pre-industrial world. They are completely different statistical populations. So the results are certainly statistically significant. So the cutoff low of the 1800s is something completely different, statistically, than the one that occurred in April 2022. Yes, the climate literacy I think is an important step towards building trust in the science, the projections of change, but most importantly on the short term, the willingness to act when an early warning arrives. But there are many colleagues here who know more than that than I do and are already working with many communities. But it is true, we see this across Southern Africa, and we also work with colleagues in Mozambique. They must convince communities to move when tropical cyclones come in. And they are often successful in convincing 50,000 people to relocate. That doesn't mean it's perfect. There are many problems there with safety and water access and food access for the evacuated communities. But the point is to convince a community to relocate for a few days. With all the risks that go along with that, also in terms of leaving property behind, you really need to have trust in that early warning and the carrier of the message. That's a big part of what we must achieve. I don't know the answers to that, but it's certainly a big part of what we must achieve. And climate literacy and understanding where the warning comes from, that it's real, that it's reliable, is a big part of the answer.
You've been talking about rainfall. The formation of Issa offshore and that formation of does that, would the longer term forecast on that suggest that might turn into a full-blown cyclone? And I think you've also suggested that we might start getting cyclones coming across the Indian Ocean south of Madagascar as it warms up. And I'm just kind of, I think the wind speeds were kind of 70 or 80 kilometers an hour during that cutoff low. And what might be the implications in terms of wind and magnifying the impacts?
I think there's another very, very important aspect to this as well, is that more intense rainfall is falling over catchments that have changed substantially since 1987, and that the choking up of the waterways with alien plants and hardening of surfaces and drainage that was built for different conditions to now is really multiplying the effects that we're seeing. So I think that our messaging as a city is that as much as climate change is worsening the rain we're getting, intensifying it, what it's falling on is so very, very important too. And so we're putting out that messaging that we need to prepare for worsening rain by preparing the ground that it's falling on suitably as well to minimize what we can do, the damage we're seeing. Thanks.
Thank you for your fascinating information. The question from us as a community and just ground level community activists and workers that have to respond in times of crisis is, if you look at the 2022 flooding, it was extreme in the numbers of people that lost their lives, and in Namtata very similar. In the tornado that hit Tonga, it might not have been by comparison, that bad, and somehow we seem to be still asking the question as a community, is that still in this conversation? In other words, is it climate change related? Where does it feature? Is it being taken seriously enough by the city and municipalities? Or is it being sort of ignored or excluded from this discussion? We'd like some guidance on that, please. Thank you.
I just want to make 2 points that I think are very useful. The first is, I think we need to be, I think the science that you presented was extremely valuable and particularly useful for scientists and for understanding how we interpret the impacts of climate change. But I think from a point of view of policymakers, we need to make sure that we don't get caught into this issue around percentages. What percentage of climate change is responsible for the impacts that we see? Because the end point of those impacts, the health of communities, the health of people, etc., is going to be the same irrespective of what is the cause, whether what percentage caused by climate change. So I think we must be careful about getting caught up in debates about, well, is this due to climate change? At the end of the day, a large percentage, as your data is showing, is because of climate change. We now need to move on and get on with protecting the health of people. The second point is around the issue about evacuation preparedness. I think what we need to do as part of our policy, and this is clearly pointed out in the People's Plan for Housing, is that we need to be moving communities away from those floodlines. We should not be now continuing to talk about issues around how many people are living below floodlines. Because in terms of risk assessment sciences and the impact on the health of communities and the health of people, we know the risk exists. We know there's a risk. So let's not sit and wait and put into place a plan to evacuate people we know are going to be impacted. Let's start now talking about pushing government to moving and building communities away from those floodplains. Thank you.
Maybe I can start with the last question. The last remark. I think what we recommended in our research is that we need to do both these things. It's not possible to overnight relocate hundreds of thousands of people, right? That's not realistic. So right now what is needed are early warning systems and disaster management responses that can evacuate people. That's the immediate need. But I fully agree. Of course, we shouldn't accept that our people should be exposed like this forever. And therefore, in South Africa, we do need to work towards finding safe land for people to live in, where they are willing to live, where they have access to the jobs, etc. So I think it's about the immediate early warning response, and it's at the same time about the long-term resilience building. Of course, the quicker we can achieve that, the better. And let us see if we can tap into some of these international funds to make it happen even faster. Then I think the climate change tells us that the climate change modeling tells us that the risks are increasing. It's important to know that climate change doubled this event in terms of the rainfall that it caused. But it is maybe even more important that there's a further doubling projected towards 2040. So if we really want to prepare for future flood events, we should also not plan only based on the past. We need to take into account the projected increasing risks into the future. It becomes even more challenging for our managers in the city planners, the urban planners, the disaster managers. The science tells us about how the risks are changing. That's why it's important. I think in terms of the question from the gentleman here about what about tropical cyclones reaching us? It's an important question. So we actually ran these simulations into a world that is 3 degrees Celsius warmer than pre-industrial and 4. That system never becomes a tropical cyclone. It never becomes a full-blown cyclone, but it causes more and more rainfall. But there's a different risk of a tropical cyclone finding its way into South Africa. Right. The Moina, January 1984, almost did that. Although the eye of the storm didn't really make landfall in South Africa. It came in from Mozambique. But in the climate model projections, we now see some tropical cyclones reaching Richards Bay. We've never seen one in the simulations going as far south as Durban. But this year there was a strange occurrence. There was a tropical cyclone that moved down in the Mozambique Channel. And eventually it moved eastwards past the tip of Madagascar into the Southern Ocean. But in some of the weather predictions, the tropical cyclone came down the coast and reached Durban. Right. It was in a weather prediction about 7 days into the future. It didn't happen. But it was the first time in my career, 20 years of looking at these forecasts, that a weather forecast said there was a tropical cyclone heading for Durban. And the reason why it's becoming possible is just because of the fact that the ocean is getting warmer. So to sustain a cyclone, the threshold is more or less 27 degrees Celsius. If the sea surface temperature is above that threshold, the cyclone can survive. So it will typically form in the Mozambique Channel. And if the sea surface temperatures keep on warming up, they may be sustained here. I would say it's a low likelihood for Durban. It's a much stronger possibility in Richards Bay to the north. It's another thing we have to plan for. And then finally, in terms of the actual flood modeling, that's absolutely true. I mean, our work is just saying to what extent was the rainfall more intense. But certainly more urbanized surfaces that accelerate the runoff is also playing a role. That's another aspect. In our current research that we are working with the city, and as I've mentioned, Umgeni Utukela Water, with a lot of data also coming from the Department of Water and Sanitation, we are now building hydrological models for Durban. And in this work, we also are investigating how land use change have changed the runoff into the rivers and eventually the stream flow. So the scientists are also trying to contribute to gain an overall understanding of all the factors that have increased flood risk, and also what we can do to minimize flood risk as we go into the next 20 years or so. You have a wonderful coalition here. Next time I'm visiting my colleagues in the city of Johannesburg, I'm going to tell them, colleagues, you're a bit behind, right? This is very, very special. But I've also learned today about the scale of the challenges here. So many communities that are living in really vulnerable circumstances. And the challenges to the city in terms of what must be done in terms of infrastructure is staggering. So what can we do? I think this last session is very important. What we can do in terms of emergency responses, the community-based flood response. That's the one thing you have control over. And it may not be able to bring, it may not be, this may not be the way to change things in the long run in terms of reducing vulnerability. There we need so much to do in terms of job creation, getting the economy going, infrastructure projects where it can help us. But at least the community-based responses can save hundreds or maybe thousands of lives in the next 10 years. And that's something you have in your own hands. So that's for me the positive thing. When I give talks, I'm often criticized that at the end of the talk everybody is depressed and scared. Now, at the end of my talk, I'm going to put the Durban, this Durban community effort, I'm going to put it there at the end, your coalition, and say how people can respond in a positive way. That's really so good. I'll just finish by saying that it is unfortunately a hard reality that the next cut of low will come to KwaZulu-Natal. It's part of the climate system. It will have the increased potential to be even more intense than what we've seen in April 2022. That's what the science says. So yes, there's an immense urgency. You have to keep your coalition going. You have to keep it well sustained. What you're doing is really important. And from my side, I do have the opportunity to now and then interact with some of the important international funding agencies that I really think needs to be behind the coalition. And that can be one contribution to your work. So thank you for a day during which I've learned a lot, and it was a real privilege to spend the time with you. Thank you very much.